Watch this terminal. A Python script. I give it one prompt. Fix the failing test. No LangChain, no framework, just the Anthropic SDK. It reads 2 files, runs the test, edits the bug, runs the test again. Green. That is a complete AI coding agent. And by the end of this video, you'll have written it. Here's what most developers get wrong. They think building an AI agent requires a framework, LangChain, Llama Index, some orchestration library with 1,000 abstractions. It does not. According to Anthropic's own engineering blog, Claude-Code's core is, and I'm quoting, a simple while loop. That's the entire architecture. Cursor uses the same pattern. Aider uses the same pattern. The open source curriculum we're following calls it one loop and bash is all you need. So why do frameworks exist? They're wrappers around this loop. Some help, most hide it, and if you don't understand the loop underneath, you can't debug your agent when it breaks. Today we fix that, from zero. Before we write a line of code, the mental model. An agent is a student in an open book exam. The student reads the question, decides whether to look something up, checks the book, reads the answer, and writes the response. If they need more info, they look again. That's it. Now map that to an LLM. The user sends a message. The model generates a response. If the response includes a tool call, read a file, run a command, the harness executes the tool and sends the result back. The model reads the result, generates again, loops, it stops when it decides it's done. The signal for done is one field in the response, stop reason. If stop reason equals tool use, keep looping. Otherwise, return. That is the entire agent. One while loop, one stop condition, one list of messages growing over time. Code time. We're following session 1 from the open source learn-claude-code repo, link below. Import the Anthropic client. Define one tool, bash. That's a Python function that runs a shell command and returns the output. Now the loop, function called agent loop. Take a query. Start a messages list with the user's question. While true, send messages to Claude along with the bash tool definition. Append the response to messages. Check stop reason. If the model's not calling a tool, we're done. Return. Otherwise, for each tool use block in the response, run the command and append the result to messages. Loop back. That's the entire agent, 22 lines. Read it twice, because everything else in this course stacks on top of it without changing one of those lines. Save. Run it. Ask the agent, how many Python files are in this repo? Watch the terminal. The model calls bash with find.name star.py pipe wc-l. The loop executes. The result comes back 147. The model reads the result. Calls bash again, this time to list the top-level folders. Gets the answer. Then the stop reason flips. No more tools. The model writes a clean 2-sentence summary. Loop exits. 3 turns. No orchestration code. The intelligence is in the model. Our job was just to keep feeding it. Pause. Honest moment. What we built is cool, but it's barely an agent. One tool, bash. Which means every file read is a cat command. Every edit is a sed command. The model is fighting the shell. A real coding agent needs real tools. Read a file cleanly, write one, edit by string replacement. So how do we add 3 more tools without rewriting the loop? This is where session 2 drops a pattern that once you see it, you'll use everywhere. Session 2. Here's the pattern. 1 dictionary. Keys are tool names. Values are functions. When the model asks for a tool, we look up the name and call the function. That's it. Look at this. Bash points to run bash. Read file points to run read. Write file points to run write. Edit file points to run edit. 4 tools. 1 dispatch dictionary. Now in the loop, instead of hard-coding bash, we look up the handler. If the tool exists, we call it. If not, we send back an error. The loop itself, unchanged. Quote from the repo, adding tools does not require changing the loop. That is the whole principle of a clean harness. Your core stays small. Capabilities plug in as entries in a dict. Now the finale, same 50-ish lines of code. New prompt, the one from the cold open. Fix the failing test in testutils.py. Watch. Turn 1, the agent calls read file on the test. Turn 2, read file on the source. Turn 3, bash runs pytest. Output, assertion error. Turn 4, edit file. 1 line changed. Turn 5, bash runs pytest again. Output, 1 passed. Turn 6, stop reason end turn. 6 turns, 4 tool types, 0 human intervention between turns. This is a real coding agent, not a toy. And the engine powering it, you already wrote it. Now the honest part. Because I respect your time. What you just built can read, write, edit, and run code. It can loop until it's done. That is a real agent. But it has no memory across runs. Kill the terminal, the plan is gone. It has no context compaction, so on long tasks it drowns in its own tool output. It has no planning layer, so on complex refactors it drifts. Those are not bugs, those are the next 4 sessions. And here is the non-obvious insight. The smart part of an agent is the model, not your code. Your code's job is to stay thin and boring. Every line of harness you add is a line you'll debug at 2 a.m. Great harnesses are small on purpose. If you want the next piece, planning, skills, subagents, and the context compression algorithm that solves the Claude forgot what I said problem, subscribe. Next video in the course is sessions 3 through 6, all open source, all built from the same 50 lines you just saw. One while loop, growing up.